Good day. So I'm doing the different tests that I gave to the AS level learners, as you can see as of this year. So I'm going to share all the tests that I'm giving to them, and hopefully you can also use it to do revision. So the following is about equations, expressions, and inequalities as well as identities. So the first question says, solve the following equation, and then you must give your answer correct to two decimal places. Now this is a quadratic equation, and whenever you're told that quadratic equations, you are supposed to give your answer to say two decimal places or whatnot, then it either means you must use the formula. Okay, now another most important thing maybe worth noting is that the quadratic equation formula in the exam, it will be included for you in the list of formula and notation. Right, so what is important here, perhaps should not waste time. Identify your A value, which is -3, your B value, which is -10, as well as your C value, which is 5. Right, so let's go ahead and say x equals to, so remember it's minus -10. So I'm going to have plus or minus here. I'm going to have the square root of -10 squared minus 4 times -3 times 5. So my handwriting is a bit rusty. It's been a while since I have worked on this. So just bear with me. So at the end of the day, if you were to punch this in on your calculator, you would get that you have x would be 10 plus or minus the square root of 160 all over, well, this is -6. So the moment you remember, as I said, it's two decimal places, it means whatever is under the square root here, the discriminant would not be a perfect square number. Okay, so basically you can therefore go ahead and then you have one answer would be -3.77, and the other answer would be 0.44. Just be very careful when you're dealing with this negative value here in your equation. Second equation is you have an equation that involves some roots, and the moment you have an equation that involves some square roots and stuff like that, you always have to make sure that you test your solutions to see if your solutions indeed work out. Okay, right, so first of all, now you have to isolate the square root. Remember, this is not the cube root, it means 3 multiplied by the square root of x plus 2. Let that equal to 2 take away x. Now the objective here is to remove that square root by squaring both sides. So you're going to square this side here, and you're going to square that side there as well. So 3 squared would be nothing but 9. The square root and the square cancel in this particular case, leaving me with x plus 2. And when you multiply this one out, you would have 4 minus 4x plus x squared if you were to multiply that out. Okay, so this is 9x plus 18 equals to, well, x squared minus 4x plus 4. Just rewriting it in that form. Right, so everything should equal to 0. So I have x squared, I have minus 4x. So again, I'm going to have that, it's going to be minus 9x, because remember now the 9x was positive that side, and then I'm going to have 18 or 4 right here, and then I'm going to have minus 18. Okay, so those ones are going over. That should equal to 0. So at the end of the day, I have x squared, so that's minus 13x, and 4 minus 18 is nothing but minus 14. Well, that should equal to 0. So you should be able to factorize this, and if you factorize this, you have x minus 14 in one bracket, and the other bracket would be x plus 1. Effectively meaning that the solutions would be x equals to 14 or x equals to -1. Now, again, you must check your solutions, and if you do check your solutions, you would realize that the only solution here would be x equals to -1. Alright, and the other one simply won't work. So let's just see how that plays into this equation. So supposedly I was to choose x plus 3, and then I choose 14 plus 2 and see if it gives me 2. Of course, underneath the square root you have the square root of 16, so that's x plus 3 times the square root of 16. That is x plus 3. Of course, the x here, let me just remove it. Remember how x is now being replaced by nothing but the number 14. So that's 14, 14, 14. The square root of 16 is 4. Now if you go ahead here, you have got 14. This is 3 times 4, which is 12. Of course, this is a big number, which is 26, and 26 is not equal to 2. So that x equals to -14 here would therefore not be valid. We are only going to consider this answer, and you can go ahead and you can check, and you will see that it will give you that correct answer. Okay, maybe I should do that for you. So I'm just going to remove everywhere where I have an x and replace it by, let's just remove the whole thing and replace it by -1 here, -1 here. So of course this is -1 plus 3 times, now 2 minus 1 is nothing but 1, square root of 1. So here you have -1 plus 3, because the square root of 1 is just 1, and 3 minus 1 is nothing but 2, and 2 equals to 2. So this solution here is the one that works. Alright, let's get to another equation. They say determine the value of p. Now it's not a secret, you can see that this becomes a quadratic equation. If you were to multiply throughout by p, it would be p squared plus 12 equals to 7p. That is if you multiply throughout by p. And then we can just go ahead and say, okay, this is p squared minus 7p plus 12 equals to 0. Of course, this should be something that factorizes as well. So you're looking for two numbers, and both of them must be negative because of this condition here. So two numbers multiply give you 12, and if you add them give you -7. Those numbers happen to be -4 and -3. So p minus 4 is equal to 0, or p minus 3 is equal to 0. So your answers will be p equals to 4 or p equals to +3. So these are the solutions. Now they are saying the next part, use the solution of A to determine. So what you're now realizing here is you have got the x square, this whole one here, the x square plus 2x plus 3, the x square plus 2x plus 3, which was previously held by our position of p, if we have to go back to our original equation. So what that means is we now know what the answer for that equation is. So simply then go ahead and say, okay, take that x square plus 2x plus 3, let it equal to 3, one solution, or the other one will be x squared plus 2x plus 3, let it equal to 4. Okay, and then we go ahead and we solve them, right? So this is going to be x squared plus 2x. Of course, if you bring that 3 over, it's just going to cancel each other. So this one can be solved by factoring out x, and then you have x plus 2 inside the bracket. So x is equal to 0, or x plus 2 is equal to 0. So x equals to -2, as well as x equal to 0. That is one condition. On this side, okay, let's just maybe separate them nicely, even Steven. So on this side, I have x squared plus 2x plus 3, take away 4, that gives 0. So that's x squared plus 2x minus 1 equals to 0. Well, you would see here that this equation does not factorize. Okay, so let me just do the discriminant. The discriminant, which is b squared minus 4, is c. So that is going to be the value of b, which is 2, minus 4, the value of a, which is a, and the value of c, which is -1. If you were to do that, that's 4, a negative and negative, plus 4. So the discriminant is 8. So that's what I mean by that. So if you do the quadratic equation formula, you would realize that this answer would be x equals to minus the value of b. In this particular case is a positive 2. So if the value of b is positive 2, then it will be minus 2 here, plus or minus root 8 all over 2a, which in this case is 2. So my solutions here therefore would be, in this particular case, you can go ahead and give your answers x equals to 0.41 or x equals negative 2.41. Okay, so all the solutions now here would be therefore x equals to 0, x equals to negative 2, 0.41, and negative 2.41. These are the solutions to that equation if the conditions are met where p or the whole x squared plus 2x plus 3 is equal to either 4 or equals to 3. Okay, so I had enough space there, so let's go to the next question. For which value or values of k will 3x plus 1 in brackets equals to x squared plus k plus x have real roots? So when you have real roots, you must understand that the discriminant would be something that is greater than or equal to 0. This is the condition for real roots, for the answers of these to be real, for real roots. Okay, so once we have determined that, we're going to equate the two, and then we're going to have obviously 3x plus 3. So what I'm doing is I'm already multiplying out, equals to x squared plus k plus x. We're going to write that into the form x squared. So now remember, I have got plus x minus 3x plus k minus 3. We say that equal to 0. So we want to write it in standard form. So this is going to give me nothing but x squared minus 2x. Well, of course, this k minus 3 here, this whole k minus 3 represents a constant. Okay, right. So let us now just quickly find what our discriminant would be. Our discriminant would be minus 2 squared minus 4 times the value of a, which is 1. Of course, I can already remove it, but let me just go ahead and then the value of c, which is that. So at the end of the day, this is 4 minus 4k plus 12. Okay, so the discriminant here would be 16 minus 4k. Okay, remember we said what is our conditions? Our conditions would be the discriminant must be greater than. So I'm going to say 16 minus 4k should be greater or equal to 0. And of course, you are now going to subtract 16 from both sides. So I'm going to have minus 4k greater than or equal to negative 16. And remember, if you were to divide by a negative, the inequality sign should be reversed. So for negative 4 into 16, that gives you nothing but 4. So the value of k should be a value that is less than or equal to 4. Right. Now I have question 5. Question 5 is divided into a few sub-questions. First, they say you must determine the roots of x squared plus 2x minus 2a equals to 0. And you must give the answer in terms of a in its simplest form. So again, using my quadratic equation formula, this is going to be x. Very important that you identify what is the value of a. The value of a is 1. The value of b is 2. And the value of c is nothing but minus 2a. So if I were to put it into my quadratic equation formula, that's minus b plus or minus the square root. So the square root of, here's the thing, the square root of 2 squared. So let's say that's 2 squared minus 4 times 1 times the value of c, which is minus 2a. all of these should go over 2 times 1. Okay, right, so let's just go ahead and simplify. This is x equals to minus 2 plus or minus, so I have the square root of 8. Now here you go, negative and negative, plus in fact you have got 8. It's not 8 but 4 in this particular case, because 2 squared is 4, so it's 4 plus 8a. Everything here should go over 2. Alright, so let me just come here. I have minus 2 plus or minus. Now if you look at the square root, there is a common factor of 4, so I'm going to take out that common factor of 4 and I have 1 plus 2a inside my bracket, and that's going to be over 2. Okay, taking out that common factor there, common factor of the common factor here of 4 and 8, which is obviously that 4 there. Good. From here on, remember, if you have something, a scenario like this, it means the square root of 4 times the square root of 1 plus 2a. That's what it means. So basically, this gives me 2 times the square root of 1 plus 2a. So just want you to see what is it that I'm doing when I get to this part. So I'm going to come here, so it's going to be x equals to minus 2 plus or minus the 2 outside now, and inside I have the square root of 1 plus 2a, everything over 2. So again, you can actually go ahead and divide that 2, because you have got 2 terms. So x would equal to 2 into that, it's minus 1, plus or minus 2 into that, they cancel, leaving you root 1 plus 2a. So what I was looking for when I said leave this in the simplest form is this particular value over here. Okay, that's going to help us to find the answers for the second part of this equation. Right, so there is quite a lot. It's just simplification and some revision on algebra work that you are supposed to be familiar with. Then say, show by means of calculation that the product of the roots, so if you multiply the two roots, so if I have to write them down, so one will be minus 1 plus 1 plus 2a, that one, times minus 1 minus 1 plus 2a. Let's see if we multiply this, what is it that we are going to get? Of course, if you were now to multiply out, it's like you're getting the difference of 2 squares, and hopefully you are familiar with the difference of 2 squares. So you have negative 1 all squared minus the square root of 1 plus 2a, that is going to be squared. That's what we mean by the difference of 2 squared, because of positive and a minus. Okay, of course this is going to give you nothing but 1 if you have to do that. Here the square and the square root, the square and the square root cancel, leaving you with 1 plus 2a. Now of course removing the brackets will give you this value, and at the end of the day, if you are now to subtract 1 minus 1, of course that leaves you nothing with the required answer of minus 2a. Okay, so remember I said it's just algebra, and we go from there. Now they are saying for 5.3.1, for which values of a does the equation x squared plus 2x minus 2a have when you have real roots? Again, when the roots are real, the discriminant should be greater or equal to 0. Now we know already from our answer in our previous part what the discriminant of this is. So let me just go back then and we find what the discriminant of that is. So all the way when we come to question 5, we already see that discriminant, of course, maybe we should just write it down if it's too much of a problem. But can you see here the 4 plus 8a? That is the discriminant of this equation here. X squared minus plus 2x minus 2a equals to 0. 4 plus 8a. Of course, if you don't know, then you can just go ahead and do the same. So you can say b squared, which is 2 squared, minus 4 times 1 times negative 2a. Alright, so this is the discriminant, so obviously that's going to be 4, that's going to be plus 8a. That's what I mean. Alright, so in order for that to be, the roots to be real, we let it equal to or be greater than 0, and then it's negative 4, and so obviously a would be then greater or equal to negative 4 over 8, which is negative a half. That's one condition. Same story when they have equal roots, and the condition for roots to be equal means the discriminant should equal to 0. So that means I will say 4 plus 8a equals to 0. Again, a will now equal to negative a half. Okay, already know how to solve that one. Then for one root equal to 0. So if you have one root equal to 0, so let me just write down what it is x squared plus 2x minus 2a equals to 0. So when one root equals to 0, if you were to substitute that answer 0 in here, okay, then what do you get? Well, you get the answer will be negative 2a equals to 0. So a will be nothing but 0. That is what we are looking at there. Okay, straightforward. Okay, when you are told one root is equal to that, you substitute that root into and see what the unknown would be. So minus 2a equals to 0. Well, of course, dividing 0 by negative 2 gives you nothing but 0. Okay, question 6. Well, of course, this is also a question I have done in past question papers, although very important that you should know, find the equation of parabola if you are given two intercepts as well as a point. Now that point is the turning point, but you don't have the y value, so we're going to use the formula y equals a, and it's a minus x sub 1 and x minus x sub 2. Alright, so you have also the point, which is the point is 1 comma negative 3. Right, so you're gonna definitely use that point into that formula. So what I'm gonna do is I'm gonna say, of course, the y value of that point is negative 3 equals to a of x minus, now you have x minus negative 2, and the other one is x minus, of course, minus 4. These are obviously the intercepts. Okay, these are the intercepts that you have here. 4 in here and the negative 2 in here. Okay, the minus is just part of the formula. Of course, now if we were to sort of clean this up, this is going to give me negative 3 equals to a. Here you're going to have x plus 2. Here you're going to have x minus 4. So perhaps here is where that point, the point of 1 comma negative 3 comes in handy. So x and y. So basically if I have to substitute the x values of that point, you see I already here started putting in my value, so let me just take it off so it's not confusing. So here I'm just going to leave it as y, and now I'm going to put negative 3 equals to a. So x is 1, 1 plus 2, 1 minus 4. Of course, this is going to be a, this is 3, and here this is negative 4 plus 1, that's negative 3. Very important that you should remember that. And then obviously here you are going to multiply that negative 3 with the other 3 gives you negative 9a equals to negative 3. Of course, a will be negative 3 over 9, which is a third. So we can actually therefore go ahead and write our equation. So our equation would be now, therefore our equation is y equals to 1 over 3, in brackets I have x plus 2 and x minus 4. And that's all. Leave your answer like that. Good. So there is one more, question 7. There is a whole big equation. Again, this equation involves some roots. So again, as I said, many ways to do this. It's totally up to you. Of course, I always like that middle term to be my guiding term. What I mean by that is I have got a 3a here minus 11a raised to the power of a half. That's another way of writing the square root of a minus 4. So this power of a half is what is going to guide me. So effectively what I'm going to say is 3a, I'm going to say that should be raised to the power of a half. Okay, I'm coming back there. Minus 11a raised to the power of a half minus 4. So when I said this guides me, this should exactly look the same as that. So the only thing that I'm going to do now, I'm going to put a square here. Okay, because if you want to multiply out e raised to the power of a half, multiply with that, you get e raised to the power of a half times that, which is just a. So this is just a decoy, another way of writing it. So this is like a hidden quadratic. And if you don't like it, you can say let k equals to a raised to the power of a half. So I'll have 3k squared minus 11k minus 4, which is sounding a little bit better than that horrible equation up there. So you can solve for this equation. You can solve this equation by means of factoring. Of course, you will have 3k squared minus 12k plus k minus 4 equals to 0, because I know the number is negative 12 and 1. So we have 3k k minus 4 plus 1 and k minus 4. Remember, this is revision work from grade 11. You should know how to factorize equations, quadratic equations for that matter. So I will have 3k plus 1 in one bracket and k minus 4 in one bracket. If I have to find the answers, k will equal to negative a third or k will equals to 4. That is if you make each bracket equal to 0. Of course, remember, we're not looking for k. We're going to substitute our k back with whatever we said with the value of a here. So this is going to be a raised to the power of a half is equal to negative 1 over 3, or a raised to the power of a half is equal to 4. So the only way to get rid of that is by squaring both sides. All right, squaring both sides. So once you do that, you are going to have a, remember, anything that you square is always positive, so this is 1 over 9, or a would be 16. Now, again, all the equations that have to do with roots, you always need to check the solution. So if I do a quick check, and remember our equation was nothing but 3a minus 11 root a minus 4 equals to 0. So if I check for 1 over 9, for example, so I have 1 over 9 minus 11, 1 over 9 minus 4. Okay, once you do that, you're gonna get quite a horrible number, I believe. So this is nothing but, if we have to grab, so it will be a third minus 11 times another third minus 4. Can you see that already? Okay, so this gives me a third minus 11 over 3 minus 4. Yeah, so it gives me about minus 22 over 3. Of course, this is invalid because it doesn't give me 0. So 1 over 9 will not work. So this one here is invalid. So what about 16? Let's just go back and check for 16. So everywhere where we have the value of a, we're going to substitute it with 16. See if we are getting to the same answer. So putting 16 over here, 16 over here. Well, of course, 3 times 16 is 48 minus 11 times 4, that's the square root of 16 minus 4. Of course, that is 48 minus 44 minus 4. Of course, all of this gives you 0. So this here is the valid answer. So a equals to 16 is our only acceptable solution. Okay, so in this particular one, there's also an additional page, and then I also included a little bit of a formula page as I go along with the tests, and I'll also include the formula that they will rightfully give you in the examination. Alright, stand by for the second test that I gave, and it also deals with equations, expressions, inequalities, and identities.